This is the cosine function tutorial. Here's your basic cosine function. Y is equal to cosine theta. And if you were to graph that in your calculator, it would look like this. It's a nice little cosine curve going through your graph. Now, if you watched the sine function tutorial before this tutorial, which I recommend you do, you got a great idea of how the sine function relates to the unit circle's y values. The cosine function relates to the values of a unit circle and the x-coordinate. So let me show you what I mean by that. If you were to just draw two dotted lines here that showed a nice height correlation between your cosine function graph here and your unit circle, you'd notice that as the cosine graph peaked at the top and bottom here, it would correlate directly to the peaks of the unit circle graph. Now, just as the y values over here on our sine function graph correlated directly to the y values over here on the unit circle, on the cosine function, like we have drawn here, the x values of the cosine function directly correlate to the x values of our unit circle. So for example, this point right here on our cosine graph, the x-coordinate of that point is 0 because you can see that that point lies on the y-axis. If you drew a dashed line comparing that to the unit circle, where that dashed line intersects the unit circle, you'll notice that that lies exactly on the y-axis too, and the x-coordinate of that value is 0 because it's on the y-axis. You'll notice the same down here on the bottom. The x-coordinate of our cosine function has a value of pi right here. If you were to travel straight down to that point that we marked, the x-coordinate there has a value of pi. And if you were to travel from our origin here on our circle, all the way around the unit circle here till you got to a value of pi, which is half the distance around, you'll notice that our x value is -1. It's 1 to the left of the origin here. So as you travel around the unit circle, for example, the first 90 degrees here, or pi over 2 radians, you travel down this cosine function. This point right here on the x-axis is pi over 2, and that's exactly this distance here from the origin up to 90 degrees. As you continue to travel along the unit circle, you continue to go down on the cosine function. Once you get to 180 degrees there, you have a value of pi, which you'll notice that's exactly there on the x-axis distance. You continue to travel around, and you get to 3 pi over 2. So if you continue that turn right there, so your x value here is 0 as you're getting back through at 3 pi over 2, then you continue along here up to the top, and that's continue along in the unit circle, all the way till you get back to where you started at 2 pi. And when you're at 2 pi, your x value on the unit circle has a value of 1. Now let's go ahead and take a look at the properties of the cosine function. The properties of the cosine function are y is equal to a cosine b theta, where a cannot equal 0 and b must be greater than 0. The absolute value of a is the function's amplitude, so remember that's half the difference between the maximum and minimum value of your cosine graph. While b is the number of cycles in the interval from 0 to 2 pi, cycles are each time the graph repeats itself, and 2 pi over b is the period of the function, and the period, remember, is the horizontal distance that each cycle travels. So let's jump into some problems using the properties of cosine functions. I'd like you to draw the graph of the following functions in the interval from 0 to 2 pi. Let's begin with the graph up top. Y is equal to -2 times the cosine of pi over 2 times theta. Now remember, this value in front is our a value. That's the amplitude of our function. And the absolute value of that is the amplitude. So the absolute value of -2 is 2. So that's the difference in the distance from the top of the function and the bottom of the function divided by 2. It's 1/2 that difference. Another way to think of that is since our graph is originating at the origin, we're basically going to be able to go 2 units up and 2 units down from the origin. Now take a look at this value here, pi over 2. Pi over 2 is our b value for this function. That's the number of cycles in the interval from 0 to 2 pi. pi over 2 is roughly 1.5, so our b value is pi over 2, which is roughly equal to 1.5. So we have 1.5 cycles in that interval 0 to 2 pi. And 2 pi over b is the period of our function. So 2 pi divided by b, which is pi over 2, would look like this. We have to invert and multiply that bottom fraction, the denominator there. So that would be 2 over pi. This would change to 1. Our pi's are going to cancel, and 2 times 2 is 4. So the period of our function is 4 units. So if I were to draw that whole thing in with our a, b, and our period value, it's going to look like this. I drew it from 0 to 2 pi. So 0 here on the origin to 2 pi, which is roughly 6.28 units. Now notice what our cycle is. I'll just start from here to here. That would be one cycle on our graph, up and back down, and then it repeats itself over and over again. Notice how there are roughly 1.5 of these. There's this one right here, that initial first guy, as it goes up and down, and then there's another half, so just a trip up basically. Just a little bit more than that because pi over 2 is just a little bit more than 1.5. You'll also notice our amplitude. Our amplitude went 2 up and 2 down. And lastly, take a look at the period of our function. Remember, the period is the horizontal distance of one cycle. So one cycle was from those 2 blue check marks at the bottom. And notice if you draw it straight up, the horizontal distance there, the distance across the x-axis, is about 4 units. Now let's go ahead and take a look at the function on the bottom. Y is equal to 3 times the cosine of 2 theta. Again, take a look at this value here. That's our a value, our amplitude. So the absolute value of that, the absolute value of 3, is simply 3. So our function is going to go 3 units up from the origin and 3 units down as it travels. Now we can take a look at our b. Our b value is what comes before the theta. In this case, it's simply 2. So b is equal to 2, and that's the number of cycles in the interval from 0 to 2 pi. Lastly, we'll plug that b value in to solve for the period of our function. So 2 pi divided by b, and our b is 2, is equal to our period. So 2 pi over 2, the 2's cancel. The period of our function must just be pi, which is roughly 3.14. So if I were to draw on a graph that meets those requirements, it would look like this. Again, it's in the interval from 0 to 2 pi, which is roughly, again, 6.28. The amplitude of our function is 3, so it goes up to 3 as a maximum value and down 3 from the origin as our minimum value. Now take a look at one cycle. That's the distance from this peak to this peak. Remember, it's just one trip of repeating y values. So that's this whole distance right here. And you'll notice our b value is 2 for this function. So in the interval from 0 to 2 pi, that cycle occurs 2 times, and you can see that it does. Also, we want to pay attention to the period of our function. The period of our function is pi, or 3.14. And you'll notice that at the end of this cycle, if you were to draw a line straight down, it occurs at roughly 3.14. So you'll notice now that we've drawn our function exactly as it was indicated in the problem here. Y is equal to 3 times the cosine of 2 theta. That's all that's involved in plotting a graph based on a cosine function. Now let's take a look at the reverse. If I were to give you a graph and asked you to write the function based on that graph. So what I'd like you to do is to determine the amplitude and the period of this cosine function. Well, the first thing I notice about our function is that it's coming in right here, down at the bottom on the y-axis, which tells me that our a value is going to be negative, because a cosine function should be coming in up top high, unless it's been shifted to the left or the right, and we'll deal with that later. So we know that our a value is going to have a negative value. Now we also know that the absolute value of a is the amplitude, so the difference from the top peak value, the maximum, to the minimum divided by 2. So on our graph, this right here, the maximum, is 0.5. And the minimum, if you do a little work here to count down, is negative 0.5. So the difference between those is a value of 1, and half that is 1/2. So our amplitude A must be 1/2. And like we said, since it comes in at the bottom of the graph here as it's coming through our origin at 0, it must be a negative value. So our A here is negative 1/2. Now to determine b, we can use the period formula for the function, which is 2 pi over b. Now remember, b is the number of cycles in the interval from 0 to 2 pi. Well, 2 pi over b is the period of the function. That's the distance to complete one cycle. So if we looked at this value to this value, that's one cycle. It goes down the graph and then back up to that same y value again. And if you look, this value on the left has a value of negative pi over 3, and this value here has a value of pi over 3. So, pi over 3 minus a negative pi over 3 is equal to 2 pi over 3, because minus a negative makes a positive here. So our period 2 pi over b is equal to 2 pi over 3, the horizontal distance to complete one cycle. Well, notice that b and 3 share the same position here, and our numerator is the same, 2 pi, which means that b must equal 3. So the amplitude of this cosine function is negative 1/2. And the b here, the period for this cosine function, is 3. So that's how you deal with cosine functions. We've learned a little bit of how to work backwards from a graph to determine things like the amplitude and period, and then how, when given the cosine function, to actually draw a graph of the cosine function. You'll want to keep practicing these and do as many of these as you can, because they can be a little bit more complex. But if you get down the basics of how to determine your amplitude and your period, you'll be fine in getting through these.